Hi students. So in this video, I am going to explain a very important concept, that is conic section. Under this conic section, we will get parabola, ellipse and hyperbola. Okay na? So this is a very important chapter. So in your JEE mains examinations, from parabola, hyperbola and ellipse altogether, you are getting one question from this conic section. So sometimes you are getting two questions are also. So very important topic here. So without skipping this video, so you completely watch this video, video lessons. So each and every point I will explain detailedly. Okay, now the first thing is conic section. First of all, why we call it as a conic section? Okay, now let us consider a cone, solid cone. Take a solid cone. Okay, now. So this is a solid cone. To this solid cone, take a plane. So if you cut the plane with a certain angle, with its what you call this perpendicular, with a certain angle, you will get different types of shapes if you observe from the top of the cone. For example, if you cut this cone like this, at the top you will get a circle. Okay, now that means if that plane is perpendicular to the axis of the cone, if the plane is perpendicular to the axis of the cone, if you cut it, then you will get a circle. If this plane, if you cut in this form, you will get an ellipse. You will get an ellipse. So if you cut this plane like this you will get a hyperbola. If you cut it like this, you will get a hyperbola. That means this parabola, hyperbola, ellipse, these are the sections of a cone. These are the sections of a cone. Let us consider a carrot. It is a carrot is there. No, if you cut on the top of the carrot, what is the shape? If you observe from the top, it will be a circle shape. Now, let us see the definition of conic section. The locus of a point P which moves so that its distance from a fixed point, that is very important here, from a fixed point is always a constant ratio to its distance from a fixed straight line. Distance from a fixed straight line is called a conic section. Once again, I am reading the definition. The locus of a point P which moves so that its distance from a fixed point is always a constant ratio to its perpendicular distance from a fixed straight line is called a conic section. First of all, we have to take a fixed point and a fixed straight line. Let us take that. Let the fixed point be this, and this is a fixed straight line. It is a fixed straight line. L is equal to 0, S is equal to fixed point, L is equal to 0 is a fixed straight line. Now the locus of a point, there is a point P which moves, that means P is a variable point, we can call it as. It is not a fixed point just like a S. It is a variable point. That means it is moves like that. In the plane it moves. It is moves like that. But how it moves? It is satisfying a certain condition. What is that condition? It's a distance from a fixed point. So let us take this P is a variable point. So here we are taking a ratio. What is the ratio? It's distance from a fixed point. That means SP. That is a distance between a fixed point, SP, is always a constant ratio to its perpendicular distance from a fixed line. What is a perpendicular distance from a fixed line? This is. So this is equal to, let us call it as PZ. Okay. So SP by PZ, this ratio. that is PS by PZ. This ratio, that means that from this variable point, the distance from the fixed point and the fixed line. So this is always a constant. So it's always a, what is saying that? So that a constant ratio, it is a constant ratio. If it is maintaining a constant ratio, that means the distance between the fixed point and the fixed line. So if it is maintaining a constant ratio, some constant, then the locus of this point, whatever may be the shape, the locus of this point is called conic section. The locus means it will get a shape. That shape is called conic section. Understand? Very easy concept this is. So on the whole, SP by PZ. So SP by PZ is a constant ratio. Here S is a fixed point, L is a fixed line. That means a P point may be here. So that means SP by PZ. P point may be here, SP by PZ. This is a P, this is a Z. Your P point may be here, that is a SP by PZ, PZ. Anywhere. So your P point may be here, SP by PZ. So if the ratio is a constant, that ratio is a constant, then the locus of this point is called a conic section. Understand? The shape may be parabola shape, ellipse shape, hyperbola shape. Afterwards we will discuss depending upon this constant ratio. Now here we are going to get the first time. There are some certain terminology we are going to introduce here. The first terminology is this P is a variable point. So it is a clear variable point or point, there is a point in the locus. That S is a fixed point. This fixed point is called locus. Sorry, this is fixed point is called focus. Focus of the conic. Fixed point is called focus. Generally, it is denoted with the letter L. Second one, this fixed line, it is called directrix. This fixed line is called directrix of the cone. So we have know the variable point, focus, directrix. Understand? Three terminology we have learned. Right. One more thing, very important thing that we are going to get is, there is a straight line which passes through the focus and perpendicular to the directrix. Passes through the focus and perpendicular to the directrix. That means this is a line. This line, it passes through the focus and perpendicular to the directrix. Passes through the focus and perpendicular directrix. This is called axis of the conic. Axis. So it's a line which passes through the focus and perpendicular to the directrix is called the axis of the conic. Understand? So variable point, focus, directrix and axis of the conic. Okay now. Now depending upon the value, that is saying some constant ratio, no? So depending upon that value, it takes different shapes, but each shape we name it as a, we will give a name. So what is the, for which ratio, for which name, that we are going to see now, okay. Welcome to here. So now we are going to see a very important concept, that is eccentricity of a conic. What is eccentricity? Now already just now we explained here. So let us take a fixed point S and it is a fixed line, L is equal to 0. Right. P is a variable point. Let us take P is a variable point. Just we have seen that SP by PM. So this is a PM is the perpendicular distance from the point to the directrix L, and S distance between S and P is SP. So this SP by PM. So the distance between S and P and M, it is called, is saying that a constant ratio. I am saying that no, that constant ratio is named as eccentricity. The eccentricity of the conic. So, we call it as, we denote it with the letter E. That means SP by PM is a constant ratio. That constant ratio is called eccentricity of the conic. Why? Because here SP is also distance, PM is also distance, both are positive quantities. So, therefore, their ratio is denoted by the letter small e, that is called eccentricity of the conic. So, depending upon the I value, so you are getting a different kinds of conic sections. The name of the conic sections are given like this. If your E value is 1, that means our distance between SP and PM is same. For example, if it is a 5 centimeters, this is also 5 centimeters. SP by PM, 5 by 5, 1. If it is a point is a P here, then SP by PM. If it is a 3 centimeters, this is also 3 centimeters. 3 by 3, 1. So, if a P is here, SP by PM. So, this is a PM. SP by PM. This is a 2 centimeters, 2 3, 3, 4, 4. That means if you join all these points, you will get a shape, you will get a conic section, you will get a shape. That name of that curve is given as parabola. The name of that curve is given as parabola. So, this is the curve name is given parabola. So, and condition is what? SP by PM value should be equal to 1. Second one. But there does not be always in the same cases, we don't know. Why? Because the P is a variable point, it moves like anything. If it is a less than 1 and greater than 0, obviously E is always greater than 0. E is always greater than 0. Why? Because maybe sometimes it may be possibility of getting 0 also. That is here we are seeing. So, 0 to 1, that if it is a E value is less than 1. So, eccentricity is less than 1. The shape of that conic is named as ellipse. If it is a E value is greater than 1, that is a 2.5, 3.5, 1.1, 1.2 like that, then the name of that conic is given as hyperbola. If E value happens to be 0, when it happens to be 0, that means this fixed point, this variable point, both will coincide. The fixed point and the variable point both is coincide. That means the SP value will become 0. Then the conic is, the name of the conic section is given as circle. If E value tends to infinity, that means what? SP value is going on increasing. SP value is going on increasing. Therefore, your eccentricity also tends to infinity. So, then the conic section is called pair of straight lines. Pair of straight lines. Understand this? So, depending upon your E value, the shape of the name of the shapes is given as parabola, ellipse, hyperbola, circle, pair of straight lines. Okay, na? I hope that you understand this concept. Now, in conic section, in particular, we are going to study about the parabola. So, systematically, we are going to study parabola. So, what is a parabola? So, what are the equation of the, so every locus will have an equation, every locus will have an equation. So, what is the equation of the parabola? That all those things we are going to see here. Okay. Welcome back. So, before going for parabola and all those equations and the discussions, there are still some more points are there regarding this conic section. First, let us discuss them, then we will go for parabola. Okay, now. So, first thing is, what is a general equation of a conic? Let us see that. So, already we have taken one fixed point S. Let the fixed point be x1 comma y1. Okay. Let the fixed line, fixed straight line, we are saying this fixed straight line, the equation of the fixed straight line is Lx plus My plus N is equal to 0. The equation of the fixed line is Lx plus My plus N is equal to 0. Let the fixed point P be x comma y. Let the fixed point be x comma y. Variable point, variable point Px comma y is a variable point, that is moves in the plane of the S and the line. Okay. Now, Already we discussed that at SP by PM, that is a SP by PM is called as an eccentricity E. The ratio of the distance between the fixed point to the variable point to the perpendicular distance from the point to the line Lx plus My plus is always bears a constant ratio, that is called eccentricity. Then how to get the equation, general equation of the conic? Okay now. So for this let us see that we will get the equation as that is SP is equal to EPM. Let us squaring on both sides. SP square is equal to E square into PM square. SP square means what? Distance between S and P, of course without square root. So this is given as x minus x1 whole square plus y minus y1 whole square into E square into PM. PM means what? Perpendicular distance from the point x comma y to the line Lx plus My plus n is equal to 0. Now what will be the perpendicular distance? So ax1 plus by1 plus c by root of a square plus b square. So this is equal to Lx plus My plus n by under square root of L square plus m square, of course whole square. Okay, if you rearrange these terms, so this square root will come for numerator and denominator, and rearrange these terms. So you will get L square plus m square into x minus x1 whole square plus y minus y1 whole square into E square into Lx plus My plus n whole square. Understand? So this is the equation of the, general equation of the conic. So depending upon the E value, the equation will change. For example, E value may be 1, maybe 2, maybe 3, but it cannot be negative. Understand? So if it is E is equal to 0, then x minus x1 whole square plus y minus y1 whole square, you will get a circle, equation. So if you simplify this, and after simplify this, you will get a general equation in second degree, that is equal to, you will get a ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So this is the equation. Ax square plus 2hxy plus by square. That means if you substitute x1, y1 values, so that is fixed value, and Lx plus My plus n equation values, if you substitute and if you simplify this, you will get a general second degree equation. Okay. So that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. So here the coefficients a, 2h, b, 2g, 2f, c. So these coefficients are taken for our convenient sake. You may say question, you may take like that, sir, here x square coefficient is a, here y square coefficient is b, but here 2h is there, 2g is there, 2f is there, why can't be it is 2c, 2a, 2b. So these equations are taken according to our convenient. Okay, now these coefficients are taken. Okay, now. So then how to recognize a conic? That means what? If you are given any second degree equation, for example, if you are given, for example, 2x square minus 2xy plus 3y square minus 7x plus 8y plus 11 is equal to 0, it is a second degree equation, general second degree equation. Then how to say that this is the equation of parabola, this is the equation of hyperbola, otherwise this is the equation of ellipse, parabola. How to recognize this? So altogether what we have? We know the coefficients 1, minus 2, 3, minus 7, 8, 11. Using that coefficients, how to recognize what is the name of the conic, what is the name of the shape of the conic that the equation represents, that we are going to see. Okay now. Welcome to this very, very important concept here. It is, consider a general second degree equation. So this is a general second degree equation. This is called general second degree equation. General second degree equation in the variables x and y. If you speak perfectly, here the variables are x and y. General second degree means you have to get second degree terms, first degree terms, constant term. These three are second degree terms, these two are first degree terms, last one is a constant term. That is why it is called a general second degree equation. Here A, H, B, G, F, C, 6 numbers are there, they are called constants. A, H, B, G, F, C, they are called constants. In particular, A is called x square coefficient, 2H is called xy coefficient, B is called y square coefficient, 2G is called x coefficient, 2F is called y coefficient, and the C is called constant term of the general second degree equation. Right, depending upon this A value, H value, B value, G value, F value, C value, the different shapes we will get. Okay, now right, that equation represents the different types of conics. First thing, you have to find out the value of ABC plus 2FGH minus AF square minus BG square minus CH square, whatever may be the equation given. For suppose any one equation is given. For example, if you given some x square minus 4xy plus 3y square plus 4x minus 8y plus 11 is equal to 0, that is a second degree equation. You compare the given equation with this general form. So here A value is 1, 2H is equal to minus 4, therefore H is equal to minus 2, B is equal to 3, 2G is equal to 4, therefore G is equal to 2, 2F is equal to minus 8, therefore F is equal to minus 4, and C is equal to 11. So all the 6 constants we got. Now substitute here. Okay, now then you will get a value. That value may be equal to 0, may not be equal to 0. Only two possibilities. Delta, we call it as that value, we call it as a delta. The delta value may be equal to 0, it may not equal to 0. If delta value equal to 0, then the equation, second degree equation represents, these are the conic sections. If delta is not equal to 0, then that second degree equation represents this section of conic. Okay, now let us see one by one. So this already you learned in first year. All you learned in first year of your +1 or intermediate course. So if first delta is equal to 0, first you find out. If it is a 0, then 3 possibilities will come. Then again you have to go for xy coefficient, a coefficient, and y x square coefficient, y square coefficient. That is a h value, a value, b value. H value, a value, b value. If h square is equal to ab, if it happens to be h square is equal to ab, then that equation represents a pair of parallel lines. Okay, now if h square is greater than ab, then that pair of lines happens to be intersecting lines. If h square is less than ap, then that pair of lines, that equation, that second degree equation represents a pair of imaginary lines intersecting at a real point. So these that is a, you will get a imaginary lines, but they intersect at some real point. Point of intersection is a real one, but the lines are imaginary when h square is less than. Only 3 possibilities. Now, is there any more possibility? H square value, ab value. H square is equal to ab, or h square is greater than ab, or h square is less than ab. Okay, now right. When your delta value not equal to 0, now we will get our chapter headings. So when your delta is not equal to 0, now see the values of a and b. So a should be equal to b, and both should not be equal to 0. That means if x square y square should not, it is not there, it should not be equal to 0, and h is equal to 0. H means what? 2h is the coefficient of xy. That means xy term should not be there. A value and b value should be equal. That means x square coefficient, y square should be equal. Xy term should not be there, and delta value. So this quantity should not be equal to 0. Then the conic is a circle. Okay, it is a conic is a circle you will get. Same like that, if delta not equal to 0, h square is equal to AB, then it is a parabola. If h square is less than AB, then it is an ellipse or empty set. See here, if h square is less than AB, it is an ellipse or an empty set you will get. So be remember that. If h square is greater than AB, then it is a hyperbola. So these are the very, very important for our heading. That is a parabola, ellipse, hyperbola. H square is equal to AB. Here h square is equal to AB means pair of parallel lines, but delta is equal to 0. Delta should not be equal to 0. If h square is equal to AB, then it is a parabola. If h square is less than AB, then that second degree equation represents an ellipse. If h square is greater than AB, then it is a hyperbola. If h square is greater than AB and together with the one more condition is satisfied, that is a plus b is equal to 0, then that conic is represents a rectangular hyperbola. Okay, now? So this is a very, very important data. So that means what? Recognition of a conic. So given a second degree general equation, so how to say that that equation represents either a parallel lines, intersecting imaginary lines, or circle, parabola, ellipse. First thing is find this delta value, afterwards h square value, AB value you find out. So depending upon these conditions, so that conic represents the various forms. Okay, now where what I am going to do is, let us take this equation, same equation, let us take this same equation, check that equation represents what type of conic. Okay, so let us see that. Welcome back. So here one second degree general equation is given, x square term xy. So let us check this equation represents what type of conic, either a parabola, hyperbola, straight lines, or pair of straight lines. Now, to do that, first of all, you compare this equation with the general second degree equation. What is the general second degree equation? Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now, write all the 6 constants, that is a is equal to 1, h is equal to minus 2, b is equal to 3, g is equal to 2, f is equal to minus 4, c is equal to 1. So first of all, what we have to find out? We have to find out the delta value. So what is the delta value? ABC plus 2fgh minus af square minus bg square minus ch square. Don't write down equal to 0. General students are happy to write that they will write down is equal to 0. We don't know that. Let us find out that. A value is 1, B value is 3, C value is 1, 2 into F value minus 4, G value 2, H value is minus 2, A into F square. A means how much? A value 1, F value minus 4 whole square minus bg square. B value is 3, G value is 2, bg square minus C value 1, H square. H value is equal to how much? Minus 2 whole square. So I hope that I wrote all the values correct. So let us calculate this value. This is a 3. So this is a 2 2s are 4, 4 2s are 8, 8 4s are 32 plus 32. 2 4s are 8, 8 2s are 16, 16 2s are 32, minus 1 plus 32. So this is a minus 4 whole square, 16 already, it is a minus 16. So this is a 2 square, 2 3 is 2 square 4, that is a minus 12. This is a minus 2 whole square, that is a 4, 4 minus 1, 1, minus 4. Now you calculate these values, so 3 plus 32, so that is equal to 35 and a minus. So 16 minus 12, 16 minus 12 is equal to 28, 28 minus 4, 32. So this is a 32, so this is a 3, so 3 is not equal to 0. Okay, now, so now we will get this second case, that means what? Circle, parabola, hyperbola, ellipse, or rectangular hyperbola. Okay, let us see. For that, what you have to find out? H square, first A and B, recognize that A is not equal to B, therefore it is not a circle. So it is not a circle. So for circle, xy term should not be there. H should be equal to 0 and A is equal to B. Therefore, both the conditions are fail here. Therefore, this equation does not represent a circle. So, let us check for. So, next we will go for H square value. What is H square value? H value is equal to how much? Minus 2. So, this is a minus 2 whole square. This is equal to 4. AB value you find out. AB value. A value is 1 and B value is 3. That is 1 into 3. That is equal to 2. So, that is a H square is less than AB. So, when H square is less than AB, let us see that what is the conic it represents. So, the conic is, so when H square is less than AB, the conic is an ellipse. It is an ellipse or an empty set. So, it is a conic is an ellipse or an empty set. Okay, now. So, like that, given an equation, we can find out this whether it is an ellipse or conic. So, first we will find out delta value. It is not equal to 0 and H square is less than AB. Therefore, the conic is ellipse. Okay, now. I hope that you understand this concept. So, dear students, in the tomorrow's class, I am going to explain what is this principal axis, what is the focus, what is the locus, what is the double ordinate, what is the latus rectum, what is the principal axis, so what is the directrix, all those things I will explain in the tomorrow's class. So, I hope that you enjoyed today's class and until then, all the best.